You're an edge liver. Don't take coffee. You're ready to try something new all the time. Lemon.
Never.
That would be going out.
Never lemon, just plain water.
Wow.
Red?
I don't know. It's good for like easy sips. Lots of like cold.
I mean, Dr. Pepper's just
No, we were working on
Alright, sorry to get you off track. Brandon, you got nobody's sure. What's your favorite drink?
Probably Coke.
Coke? Nothing better than a fountain Coke at McDonald's. Okay, that's like
Sprite at McDonald's.
oh, Coke. So Coke from McDonald's is better than anywhere else. I don't know, hardly ever go to McDonald's.
I don't even remember.
I'm gonna win.
Yeah, me either.
All right, geometric sequence. Obviously, you got the same setup. You're gonna have a sequence. Instead of D, we call it R. And now to figure out D, that you subtracted one term from the previous term, you're going to divide. Okay, to figure out what the R value is. Okay, so you have a geometric sequence or progression. There's a number R such that each term except the first is obtained by multiplying the previous term by R. So to get to the next term, you multiply. Okay, to figure out R, you're going to divide term by term. The number R is called the common ratio, and that should go in that spot right there. I know you on your paper it says we have. I'm not sure why that's there, but right where you have that gap, put in A sub n plus 1 divided by A sub n equals R. N is greater than or equal to 1. All right, let's take a look. Or let me just put a sequence up here. All right, so if I start with 5, and I tell you the next number is 10, and I say it's geometric, what does the next number have to be? No, 15. It's geometric. Have to be 20, because what do you multiply 5 by to get 10? You multiply by 2. So then the next one would be 20, then 40, then 80, then 160, and so forth. Okay. Now, a geometric sequence can be defined recursively. Remember, recursively means you use the previous term to get the next term. Okay. So the recursive formula is A sub n plus 1 equals R times A sub n. All you're doing is multiplying the previous term by that common ratio, that R value. In this case, it was 2, or for that last example. Now, let me go backwards for a second to this right here. All right, here's your first term. First term, second, third, 20 is my third, fourth term, fifth term, sixth term. All right, this is just 5. This is 5 times 2. We agree with that? Obviously. The next one you can represent as 5 times 2 to what power? Second power. And the next one would be 5 times 2 to what power? 2 cubed, and then 5 times 2 to the 4th, and 5 times 2 to the 5th. All right, so because basically you're multiplying by 2 every time, so basically we're introducing a bunch of 2's. How does the power relate to the term? Okay. It's what?
The term minus 1.
It's the term minus 1, right? So the 6th term, we take it to the 5th power. 5th term is 4th power. So when you're doing this, so find A sub n, it would be the first term times the R value. Oh, hold on. 5 times 2 to the n minus 1, right? Does that make sense? All right, now don't write anything down yet. Okay, so this is what we're talking about. This is what we just built up. So every geometric sequence can be written in this form. So there's your first term, then it's times r, then times r squared, then r cubed, and then in this case here, r to the n plus 1, where r is the common ratio. This is the formula for the nth term. So where it says, whoops, a sub n plus 1, hold on here, I gotta make sure we're good. Did I miss that one? All right, that should go where it says a to the n plus 1. Sorry about that. See where it says that on that next little gap, a to the n plus 1 equals r times a to the n. Okay. N is greater than or equal to 1. All right, so now we're going to talk about the nth term, a sub n. Okay, that's that next one there. Equals a sub 1, the first term, times the common ratio to the n minus 1. Okay, for n is greater than or equal to 1. Okay, so we had 5 and 10 and then 20 and then 40. So like this would be your first term here. That would technically be 5 times 2 to the 0 power. And this is 5 times 2 to the first. 5 times 2 squared, 5 times 2 cubed. Okay, so it's always going to be n minus 1 there for that power. Make sense to this point? All right, now this next one is the first two are absolutely straightforward here. What's the first term? That is just 3. Okay. What is your R value? Well, here's where this comes into play. If you, obviously, in the most part, if it's like nice whole numbers, the R value is going to be pretty clear. If it's not, sometimes you get decimals, sometimes you get fractions, the R value won't be as obvious. So you got to divide. You take one term divided by next, 24 divided by 12. So 24 divided by 12 is 2. And then 12 divided by 6 is 2. And 6 divided by 3 is 2. As long as they're the same, that's going to give you your R value. Like I said, if they're nice whole numbers, it's probably going to be pretty obvious. All right, how do you write a sub n? That's just what you did right above. How would we give the general form? Well, it's a sub n equals the first term times r to the n minus 1. So we know the first term, we know the r, so a sub n equals, the first term is 3 times 2 to the n minus 1. All right, that's what they want there. Could you find the 30th term? Yeah, just plug in 30, n minus, 30 minus 1. So that would be, you just do that. So you can find any term you want there. All right, so for this case here, it says find the 23rd term of a geometric sequence whose first term is 10 and common ratio is 1.2. All right, before you do that, I want you to write out the first 4 terms. What are the first 4 terms? Okay, do that first. I want to make sure that it makes sense how to find them. And don't make, just what's the first term got to be? 10. You don't ignore that. Don't. Some people skip that and do the next one. All right, first term is 10. Then find the next 3. All right, Justin, what do we get for the second one? 12. How about the third one?
14.4.
And then how about the fourth one?
17.28.
17.28. So if you were given this sequence, I mean, it wouldn't be obvious what the R value is. I mean, at least not to me. Like, you go, oh yeah, multiplied by 1.2. So you'd have to divide to figure out what that value is. All right, we want the 23rd term. We'll use the fact that a sub n equals the first term times r to the n minus 1. We'd let n equal 23. So my 23rd term, first term is 10 times 1.2 to the 23 minus 1 or 22 power. Now you're going to get a really, you're going to get a decimal. Okay, non-terminating decimal. Just round it off to the nearest hundred for this case. Okay. 552, right? 0.0 something? 552.06. All right. So that'd be your 23rd term for that. Common ratio 1.2, first term is 10. So we change the first term, obviously the rest of it would change as well. Now with everything, we want to add them together. We still want to do this. All right, so fill this in exactly as it is, and then I'll explain a couple things. Okay, the actual formula that we're going to use. Okay, that's the formula. If you're given, because you can be given a geometric sequence in two forms. You can be given the sequence, like where they list out the numbers, or they will write it in this form. Anytime you see this where it says the sum of a sub 1 times r to the I minus 1, that is guaranteed to be a geometric sequence because it matches, okay, our general form. Okay, it matches that. It would be in that format. And that guarantees it's going to be geometric. This next piece here, where is it at? All right, don't write this down, it's not, I didn't leave you room on your notes, but just pay attention. I want you to see why. You could do this one two ways. You could just do it the old-fashioned way and plug this in, because this says I want the sum from I equals 1 to 4 of 3 times 2 to the I minus 1, right? And I could plug in, first number I'd plug in is 1, the last number I'd plug in is 4. We can do that mentally. What do we get when we plug in 1? No. The answer will end up being will be 3. There you go. Good correction. Because it's 1 minus 1, because that's going to be 2 to the 0. So my first term is going to be 3. Plus, what's my second term going to be? 6. What's my third term going to be? 3 minus 1 is 2, 12, and then it's going to be 24. Is that a geometric sequence? Does it multiply by what? 2. What's the sum of that geometric sequence? 3 and 6 is 9. 9 and 12 is 21. 21 and 24 is 45. Agree? So that is 45. So if you were asked to compute that, you would just probably write it out and give me 45. I understand that. If it looks like this, guaranteed to be geometric, which means I can use this format here. A sub 1 times 1 minus r to the n over 1 minus r. For this one here, yes, that equation is probably more difficult, and you could do it this way. But I just want to make sure you understand how they're the same. What's my first term? My first term is whatever this number here is. It's going to be 3. What's my r value? 2. So I'm going to say my first term is 3. 1 minus 2 to the n power, well, n is going to be that 4 over 1 minus 2. What's 2 to the 4th is 16, right? 1 minus 16 is negative 15. So that gives me 3 times negative 15 over negative 1. Well, that's negative 45 over negative 1, which gives me 45. Okay? So these are equivalent. You could write it all out, add them up. You could use the formula. Once I know it's geometric, I can use that formula. Okay. So now this would be where A is. So you got 2/9, you got 2/3, 2, 6. Now I want both of these written in, this one and the next one. Final answer is a fraction, no decimals. And so we're going to work with the fractions. You can use your calculator, but I still want you to write it in fractions. All right, one thing you're gonna have to do is you're gonna have to look at it, and I'm not gonna tell you whether it's arithmetic or geometric or neither. You're gonna have to figure it out. If they're all nice positive numbers, yeah, it's easier, but now this one's probably not quite as obvious. Well, since this is a geometric section, that's probably gonna be that way. All right, what's your R value, or how can we figure out the R value? Matt?
R is 3, and you figure it out by taking one term and dividing it by the previous. So, like 6 divided by 2 is 3, and then 2 divided by 3 is 2/3.
You would do 2 divided by 2/3 is what you want to do,
Yeah,
which is 2 times 3 over 2, which will be 3. And then we would take 2/3 divided by 2/9, which is 2/3 times keep, change, flip. And then that will become 3 as well. So you gotta verify. So we get 3. So I can use that formula. What is that? S equals a sub 1 times 1 minus r to the n, correct, over 1 minus r. Is that it? Okay. So I can use that formula. What's my first term? 2/9. First term is 2/9. What's my r value? 3. So I get 2/9 over 1 minus 3 to what power? 12th power over 1 minus 3. Don't worry about the 2/9 yet. What's 1 minus 3 to the 12th? 440. So I get 2/9 times negative 531,440 over negative 2. Okay, over negative 2. All right, it's not going to come out to be a nice whole number. That's okay. A couple ways you can go about this different ways. One thing I'm going to do is I'm going to take that 2/9 instead of multiplying across. I'm going to divide it by negative 2. What's 2/9 divided by negative 2? Use your calculator. If it gives you a nice number, fine. If it doesn't, convert it. But 2/9 divided by 2, you're basically cutting 2/9 in half. So it should be what? 1/9, but it's going to be negative. Yeah, you get negative 1/9? All right, so now this is going to be negative 1/9. And it's a negative times a negative. So in the end, so times negative 531,440. Negative times a negative is positive, so it's going to be 531,440 divided by 9. The only question is, and I want you to leave it like that for now. That's how they're going to leave it 9 times out of 10. Does it reduce any further? Does any number go into both 9 and 531,440? There are only 2 things you need to check: 3 and 9. Okay, and 9 cannot go into anything that has a 0. Okay, 3 could, but you would have to double check that. 9 just could. 9 could, but I don't think it does. Did anybody check? It does not. All right, so that's our answer. So what we got here is we got a geometric, and these are nastier than arithmetic. Okay, they're not as nice. 12 terms. We keep that going for 12 terms. We add them up. We get that 531,440 over 9. All right, for part B, that second one. The sum, I equals 1 to 8 of 4 times 1/2 to the I minus 1. Okay, if it looks like that, you could write out all the terms. But we know it's geometric because it satisfies that definition. Okay, so if you have a constant, now if there's no number in front there, you could put a 1 in front of there, times 1/2 to the I minus 1, then I know that this is geometric. Okay, and if it's geometric, I can automatically jump to this equation. All right. You still got 2 options. You still write everything out and then add them up. other options, we can use this formula. Okay, so I'm going to use the formula for class. The first term is what? First term is what? Will we remember, Anthony? 4. It's always going to be whatever that constant is, or you could plug in 1 and just verify it. So the first term is 4. 1 minus, what is my R value going to be? The way this is written. R value is going to be the 1/2. So it's geometric with the first term equal to 4, the R equal to that constant to the power. So 1 minus 1/2 to what power? And what's my n is going to be 8. And then 1 minus 1/2 on bottom. All right. Again, try to hold off on using your calculator until necessary. What is 1/2 to the 8th power? 1/2 to the 8th power. Really, you got to take 2 to the 8th power. You can use your calculator for that. What's 2 to the 8th power? 256?
Mm-hmm.
So it's going to be 4 times 1 minus 1 over 256. Divided by 1 minus 1/2 is 1/2. I'm going to do two things at once. What's 4 divided by 1/2? 2. 4 divided by 2 is 2. It's 8. So you're taking 4. Now if you think about it, like as a kindergartner, you're taking 4 blocks and you're cutting each block into what? Half. So how many blocks you got? 8. So 8 halves go into 4. Don't touch your calculator. What's 1 minus 1 over 256? Do you know how to do that? Just look at it. Okay. Anna, what do you get?
It's 255 divided by 256, and then you multiply it by 8.
So it's 255 over 256. Okay, because 1 is 256 over 256. So anytime you're subtracting 1, you should be able to do that. Now, here's what I do. I wouldn't multiply yet, because what can you test? To make things maybe a little bit simpler. This is really 8 over 1, right? So I would test to see whether 8 and 256 have any like terms. Well, 8 go into 256. How many times? 32. So that means that this cancels. Canceling is such a nice thing. 255 over 32. And then you would see if that would reduce any further. I don't think so because 3 or 5, I'm just trying to think of odd numbers, or 7, don't, only thing goes into 32, 16, 8, 4. Okay, so I think we're good. So 255 over 32, I'm going to leave that as my answer. Okay. So not as, like I said, not as pretty. Okay, you get some nastier numbers, fractions, so forth. So that's a geometric sequence. All right, flip it over in the back. All right, this first part isn't on there yet, so just kind of pay attention. All right, what means happening with that dot, dot, dot? Keeps going. All right, according to this, does it end? No, it doesn't end. So this is a never-ending sequence. What is going to happen now if I add them all up? So I got pluses here, but what if I put pluses between everyone else? What do you think its sum would be? Infinity is your natural guess. Is not, though. Not in all cases. So here, let me see if I can give you a picture.
Isn't it like 3, but like approaching 4?
Ah, okay. It's actually going to be 4. It's actually going to be 4.
Oh.
Okay, so now let's see if I can give you a picture of how it works. I got a square, right? What's the area of that square? 4. All right, that's sequence. What am I multiplying each number by? 1/2. So I'm going to start with 2, and I'm going to pretend I got a block of area 2, and I'm going to put it in that square. So my first block has area 2, and it would be this right here. Make sense? What's my next block have an area of? 1. And I can go right here. So that has an area of 1. And my next block has an area of what? a half, which we can go here. We agree with that?
Mhm.
And then my next block has an area of what? A fourth. And the next one is an eighth. And my next one is 16th. And then 32nd, 64th. So what's going to happen each time? Does that next block ever fill up what's left? Always fills up how much of it? Half. And then we fill in half of that. We fill in half of that. And if we go infinitely, what's going to keep happening here is this keeps getting cut in half, and eventually we're going to fill it all in, okay, except for a microscopic piece there. So what's that total area going to be? 4. So what's this going to add up to? 4. It's going to have to 4, okay, because it's going infinitely. Okay, so eventually it's just going to fill everything in. Will it ever get bigger than 4? No. So hopefully that'll give you at least an idea of why not. Because like we always have half left, and we keep cutting it in half, cutting it in half, cutting it in half. We're never going to overflow it. Okay, so we do have a formula. If you have an infinite sequence, infinite doesn't have an ending point. Here's the key though: your R value, the absolute value, has to be less than 1. Has to be less than 1. So you got to be multiplying by something like a half or 2/3 or 3/4 or an 1/8. Cannot be bigger than 1. Then here's your sum. Okay, we're taking a sum from I equals 1 of this geometric sequence, and then this is the actual formula that we apply. If R is bigger than 1, so if I start with 3 and I multiply that by 2 and I multiply that by 2, clearly if I keep going forever, it's going to go to infinity. Okay, only if it's less than 1. So using that formula, a sub 1 over 1 minus r, just show you that it works. So S equals a sub 1 over 1 minus r. My first term is 2. 1 minus a half gives me 2 divided by a half. So I cut 2 into how many half pieces? 4. So it's going to be 4. All right, now take a look at, write that one down. Write that one down. First thing you got to identify is what the R value is. See what you come up with. So 2 plus 3 halves plus 9/8 plus 27 over 32. To me, it's not obvious. Like I can't just look at that and say, oh yeah. So it's 2. Don't be a spoiler. Oh, you should do that by hand just to make it a little more fun. Type into a calculator. It's so fun. Spits out an answer. It is. Okay. So 3/4. Okay, did you get that? Now, it is, to me, it's not obvious. So you're basically taking 27 over 32 divided by 9 over 8. 9 over 8 divided by 3 over 4. Or 3 halves. 3 halves divided by 2. First one's not that bad. But remember, 27 over 32 divided by 9/8. 27 over 32. Keep, change, flip, and canceling. So everybody's friend here. You cancel. Remember, anything from top to bottom. 9 goes into 27 3 times. So that's a 1. 8 goes into 32 4 times. Reduces to 3/4. All right, I'm not going to do them all. R is 3/4. Is it less than 1? Yes. So that means that sum will add up to a number. It won't go up. It won't go to infinity. What's that number? Well, S will equal first term over 1 minus r. First term is 2 over 1 minus 3/4. 2 divided by 1/4, which is 8. So that sum is 8. So you can think of a rectangle of 8, filling it in piece by piece by piece. Never going, and then at the very end it'll fill all the way in. Okay, that's geometric. Geometric. All right, page 1026. I want to take a look at 19 because that was causing some confusion in the first part. Yeah, I'm just gonna change that 19 to a 13. Okay. 19 is geometric. They give it to you, and you would have to actually list the terms and be able to write it out. It just wasn't one we did exactly. So just do 13. All right, so you can get done here.
Can you explain the square thing to me again?
Square thing. Oh yeah.
Yeah, where you divided it up.
Yeah. Give me a second. Stay right here.
You would have to divide. Okay, so I'm right. Alright, if it works.